I'm Peter Rowland, Managing Director at Micro-X Limited. The innovation we've submitted for these awards is the Rover Mobile Medical X-ray Unit. It's an ultra lightweight mobile X-ray for bedside imaging, and it's designed specifically to meet the needs of mobile and deployed military medical facilities. It's a fraction of the size and weight of conventional X-ray machines because in the past the military haven't been able to deploy the 600 or 700 kilogram units that most conventional bricks and mortars hospitals used. We're the first company in the world to develop a cold cathode X-ray tube. The cold cathode technology makes X-ray tubes extremely light, and therefore the equipment that uses the X-ray tube is a lot lighter as well. So the big innovation is getting that performance in something that's much lighter and therefore deployable. Defence forces around the world have a policy of trying to provide the same level of healthcare for people who go in harm's way as they would receive if they were at home. And they managed to do this very successfully in deployed Role 3 medical facilities, with the one exception of radiology. Our technology allows a deployable weight of 95 kilograms to offer the full medical X-ray capability that you'd expect in a first-tier acute hospital. Every X-ray tube built up till now has used a heated filament as the electron source, a bit like the old-fashioned incandescent light bulb. Micro-X is using the equivalent of an LED.
Well, the Nano is built around the carbon nanotube technology. This is a real game-changing technology because it enables a very, very small X-ray tube, 1.5 kilograms compared to conventional tubes, which are around that 18 to 20 kilogram range.
This is Micro-X. This is the future. This is the X-ray tube that sits inside of the Nano cart. This X-ray tube replaces a conventional heating element with carbon nanotubes, and that enables us to take an X-ray tube that's this big and bring it down to this big without compromising performance.
When you've got an X-ray tube on the end of a reticulating arm, you can reduce the weight of the system by a ratio of about 6 to 1. So every kilo that the X-ray tube loses, the cart can lose 6 kilograms.
The product itself is lightweight, it's easy to maneuver, it has no internal motors or drive mechanisms or solenoid or friction brakes. Everything's balanced, and that's because of the lightweight carbon nanotube.
The auto industry is very much the university for advanced manufacturing, and Micro-X have worked very hard to bring that approach to our business as well. We've brought the people from that industry in, the culture and the supply chain.
Everyone at Micro-X has a background in highly regulated industries, which means quality is our second nature.
We've worked on the approach of quality and efficiencies around manufacturing that the auto industry has. They produce cars at high rates and still have the highest levels of quality.
Our next application using our carbon nanotube technology is our mobile backscatter imager. This uses our ability to make multi-emitter tubes and scan an object to make an image, effectively giving us X-ray vision inside an object. This is very useful for bomb disposal applications and threat identification, where we've eliminated the need for a human to interact with the object.
Micro-X will continue to develop innovative products in both medical imaging and security imaging. Our aim is to develop, in fact, only develop products which have no competition. This is a whole new imaging modality that's available through the CNT technology. The team that worked on this project, a group of engineers in Adelaide, that's the core of our engineering, are extremely bright people. But our design focus is very, very much driven by users. We design to solve users' problems. We were very lucky in that we got a contract from the Department of Defence to create a technology demonstrator. And as part of that, I was able to spend some time with the Australian Army in a deployed medical facility up at Shoalwater Bay on a big exercise, the biennial Talisman Sabre. So it was really good in that to see the hospital set up and how the workflows worked in the hospital and the problems that they were having in radiology with the existing equipment. So that understanding how an operational deployment works was really helpful to as a place to start the design of this new equipment.